wabarakatuh. My name is Muhammad bin Abdul Hamid from BMMA 1/1 and from Group 10. Today we want to present our mini project that is torsional loading evaluation from actual structure. Okay, for the introduction, torsion is the twisting of an object caused by a moment acting which is subject torsion load about its longitudinal axis. A moment tends to cause twisting is called torque and resulting stress is known as shear stress. A good example is a wrench sleeve 90-degree where force is applied on each side of the handle that will turn the wrench. The wrench that will then apply a force at each side of the nut slit that will turn the nut tires.
Okay, the problem statement. We can see the problem statement. The left. We got actual structure. That is we're using wrench sleeve, 90-degree wrench sleeve. So, and the right we see the free body diagram from the actual structure. Next. Okay, the tool is using the wrench and then the socket opener. Next. Okay, this wrench sleeve using steel, and the length of wrench is 0.43 meter, and then the length of B is 0.08 meter, and the thickness we got 0.032 meter, and then the shear model of the steel we got 79.3 gigapascal. So the polar moment, we use a polar moment equation, and then we substitute the thickness into the polar moment, and then we got 1.0294 multiply with 10 the power of a -7, and then the shear stress in the shaft, the T max we got we use the formula shear stress, and then we got the T is 5.01.196 kilonewton meter, and then the equation of equilibrium we got the force is 11865.503 kilometer. Next. Okay, the safety of the factor of safety. You use factor of safety equal with T max divide T allowed, and then T max we got 510.16 kilometer as based on the research, divided 1 to 0 Newton meter. We got 425.6365, and then the condition is safe. From the table we got equipment spring large heavy duty, the FOC 4.5, so the condition is safe. Next.
Okay, next for the discussion. The first one, the mechanism of the torque work as the moment of twist structure. Axial load is produce a uniform or average stress over the cross section of the object. A torque creates a distribution of stress over the cross section. When a torque is applied to the structure, it will twist along the long axis of the road, and its cross section remains circular. The more the angle of twist, the larger the shear strain. Okay, J is denoted as the second polar of moment or second moment of inertia. J is polar of moment unit. Okay, the larger the moment of inertia, the less the beam bend. As the equation, T equal to torsion T P over J. Okay, next. Okay, the number three is the equation Ix equal to integrate y square dA. Equation number two is Iy equal to integrate x square dA. Y is the distance from the x-axis to an infinitesimal area dA. X Then x is the distance from the y-axis to an infinitesimal area dA. It is a dynamic motion of object. Number four is the unit for polar moment for solid road is J equal to pi over 2 multiply with thickness square. And number five, Hooke's law is shear to see how they are related. Hooke's law enables to calculate the angle of twist where the formula are as shown below. Shear Hooke's law equal to TL over GJ. Okay, last but not least, factor of safety. It is when the ration of the ultimate strength of member of piece of material per miscible stress when in use. It can be simplified when is the ratio between the forces that will be applied to component in a system and the minimum breaking strength of the component. From the equation, FOS, factor of safety, equal to torque max divided by torque allow. Okay, next.
Okay, for the conclusion, we can conclude that this mini project has successfully taught us on how to apply our knowledge of calculation to calculate the polar moment of inertia, torque, torsion, and maximum shear stress. It also can be concluded that this mini project use Hooke's law principle to relate the both of the stress and strain. Okay, this is our group 10 poster. Okay, that is from we all. Thank you.
Okay,